Good afternoon everybody. Today my topic of lecture is metallurgy of iron and steel. As we know that iron is generally present in earth and it is mostly present in earth in combined state, that is in the form of metal compound. The important ore of iron are hematite, that is Fe2O3, magnetite, Fe3O4, limonite, Fe2O3 and associated with 3 molecules of water, iron pyrite, that is sulfide ore, FeS2, Siderite, that is FeCO3, that is carbonate ore. These are the mainly ores associated or the present in the earth. Before starting with the metallurgy of iron, we can tell that the iron is mainly, there are 3 varieties of iron present in the earth. The one is the cast iron or the pig iron, second one is the wrought iron and the third one is the steel. So, first what is the cast iron or the pig iron? The cast iron or the pig iron, it is the most pure form the iron. That is the most of the impurities are associated with cast iron or pig iron. The most important impurity present in this is that is the carbon content. That is, it contains highest proportion of carbon, that is 1.5 to 4.5%, and the other impurities are sulfur, phosphorus, silicon, manganese, etc. And due to the presence of these impurities, it is generally hard, brittle and cannot be welded easily. And the second form of iron, that is the wrought iron, and this wrought iron, it is the purest form of iron, means it contains lowest percentage of carbon. The percentage of carbon present in this wrought iron is approximately, that is 0.2 to 0.5%, and the wrought iron is generally soft, it is malleable and ductile, that it can be drawn into sheets and wires and it can be welded easily. The third form of iron, that is the steel, and this steel, it comes in between the cast iron and the wrought iron. That means the carbon content comes in between the cast iron and wrought iron and it contains 0.5 to 1.5% of the carbon. Next, now we will start with the how can we extract the cast iron or the pig iron from its ore. The main or the chief ore of iron is hematite, that is Fe2O3. The various steps involved in the extraction of iron are crushing, grinding and screening. This is the first step. The second step was the concentration of ore. The third step was the conversion of any metal compound to its oxide form. The fourth step was the reduction and the fifth step was the refining. We will start it one by one. The first step is crushing, grinding and screening. As we know that the raw material which is available in the earth, that is hematite ore, it is available in the form of big rocks. So, these big rocks are put into jaw crushers to crush them to a small pieces. Then these small pieces are put into sawmills to grind them to a fine powder. Then screening is carried out to separate the bigger particles from smaller particles. The smaller particles are carried forward for the second step, that is for the concentration of ore, and the bigger particles are again put into sawmills to again grind them to a fine powder, so that they can be again used for the concentration of the ore. The second step for the extraction of cast iron, that is the concentration of ore. The concentration of ore means that is the removal of impurities from the ore. The removal of impurities of the ore means that the ore is always associated with the two things, that is the metal compound as well as the impurities. if we remove the impurities from the metal compound in any way, so the metal will become, or the ore will become mainly rich in metal compound. So, in the case of cast iron or the extraction of iron from the hematite ore, the concentration of ore is done by hydraulic washing, that is the washing by with water. That in this case we simply take a beaker, we put the impure ore into it and we start passing the water, or we start putting the water from one side of the beaker, and the lighter impurities or the lighter earthy impurities, that will be start washing away along with the water from the other side, and the heavier ore particles, they will be left behind into the beaker. So, in this way we can remove the impurities from the ore, and the ore will become mainly rich in the metal compound. Now, the third step, that is the conversion of any metal compound to its oxide form. Although the hematite ore is already in the form of oxide form, so there is no need of the third step, that is the calcination and roasting. But as the hematite ore is always contaminated with iron carbonate, that is FeCO3. So, the calcination roasting both is generally carried out. So, when we do the calcination, that is heating the ore in the absence of air, and roasting is a process that is heating the ore in the presence of air. As both steps are carried out in the case of hematite ore, so during these processes the three steps will take place. Number 1, the first of all, the moisture will gets evaporated both in calcination as well as in roasting. Second, as the roasting is carried out, the impurities if present like sulfur, arsenic and phosphorus, like if they are present, they will get converted to their corresponding oxides. For example, sulfur, that is sulfur will get react with oxygen and it will form sulfur dioxide. Arsenic, it will react with oxygen, it will form arsenic oxide. Phosphorus, it will react with oxygen and it will form phosphorus pentaoxide. All these three oxides, sulfur dioxide, arsenic oxide and phosphorus pentaoxide, all these three oxides, these three are volatile in nature. As these three are volatile in nature, they will escape out and the impurities will be removed. And as the hematite ore is always get contaminated with iron carbonate, the iron carbonate present in the ore, it will get decomposed during calcination to ferrous oxide and carbon dioxide. Carbon dioxide being gas, it will escape out and the ferrous oxide converted from the ferrous carbonate, it will further get oxidized to ferric oxide immediately by the process of roasting. Otherwise, if it will be remain as such, it will react with silica to itself forms the slag, and in this way there will be a loss of iron. Otherwise, the ferrous oxide will get roasted or will react with oxygen, immediately get converted to hematite, that is Fe2O3, and in this way we can prevent the loss of iron. So, it means the although the hematite ore that is already in the form of oxide form, there is no need of the process of calcination and roasting, but due to the contamination of iron carbonate, we have to do the process of calcination and roasting in the case of hematite ore, by which the moisture evaporated, the impurities like sulfur, arsenic and phosphorus, if present, they will convert it to their corresponding oxides and will escape out as their volatile oxides, and the carbonate, the contaminated with oxide, that will get converted to ferrous oxide, and this ferrous oxide will get converted to its ferric oxide immediately by the process of roasting, and in this way we prevent the loss of iron, and so that is why the calcination and roasting is carried out in the case of hematite ore. So, the three processes that is happens till now, that is crushing, grinding and screening. The second one was the concentration of ore, and third one was the calcination and roasting to convert the ferrous carbonate to ferric oxide. The fourth step involved in the metallurgy of iron, that is the reduction of the ore, or you can also name this step conversion of any metal compound to its metal. The reduction of the ore is carried out by carbon, and this process is also named as smelting. The roasted ore is smelted or reduced with carbon, and this process is carried out in a blast furnace. The blast furnace is a tall cylindrical furnace made up of steel lined with fire bricks, and this furnace is narrow at the top and has cup and cone arrangement for the introduction of charge, and it is having an outlet for the waste gases. At the base of the furnace, it is provided with a tapping hole for withdrawing molten iron and a second outlet for removing the slag. There is an arrangement for tires for the introduction of hot air at the base of the blast furnace. The charge which we fed at the top of the furnace, that is consisted of roasted ore, coke and lime, which is mixed in the ratio of 8:4:1, and this is introduced at the top of the furnace, and a blast of hot air is blown upwards with the help of tires which are present at the base of the blast furnace, and the coke which is put at the top of the furnace in the charge, this will be served as fuel as well as the reducing agent, and while the lime which is put into the charge, that will serve as a flux. As we know that flux is a substance which is added and just to remove the impurities, and the flux, it will react with the impurities and convert the impurities into slag, which can be easily removed from the side hole. Now, what happens in the blast furnace? The total process take place in a different zones. Now, the different zones consist of 4 types. One is the zone of combustion, second is the zone of fusion, third is the zone of slag formation, and fourth one is the zone of reduction. The first 2 zones, that is the zone of combustion and the zone of fusion, that occurs in the base of furnace, and the third one, the zone of the slag formation, that is present in the middle of the furnace, and the zone of reduction, that is present or that occurs in the top of the furnace. Now, how the reactions occurs in different zones? The first starts with the, let us take the case of zone of combustion. As the name indicates, the zone of combustion. Here first of all, what happens? The coke which we have fed at the top of the furnace, that is the coke, it burns in the presence of oxygen which we are feeding from the tires, or we are entering the air from the tires. So, coke will burn in the presence of oxygen and it will form carbon dioxide, and carbon will react with oxygen and it will form carbon dioxide. As we know that this reaction is exothermic in nature, and we know that the exothermic reactions are those reactions in which heat is liberated. So, the lot of heat is available or evolved during this process. As the lot of heat is evolved during this process, the temperature of the furnace above the tires, it will rises, and the temperature above the tire will reaches to 1500 degree centigrade. And the second one is the zone of fusion, and this is above the tires. Here what happens, the carbon dioxide which is formed during the zone of combustion, this will rises upwards. So, when it will rises upwards, it will come in contact with the coke which is coming down, which we have fed at the top of the furnace, and this carbon dioxide, it reacts with the coke and it will gets reduced to carbon monoxide. So, in this case, the coke will act as the reducing agent, and now this reaction is endothermic in nature. This reaction is endothermic in nature. As this reaction is endothermic in nature, so the temperature will gets lowers down. As the temperature will gets lowers down, so the temperature of the furnace will gets decreases to 1200 to 1300 degree centigrade. So, as the temperature above the tires was the 1500 degree centigrade, so the temperature in the blast furnace above this zone will becomes 1200 to 1300 centigrade. And the carbon monoxide formed here, this will reduces the iron oxide to spongy iron. This iron oxide which we have fed at the top, that is the, you can say, the roasted ore. So, what happens, Fe2O3, that is the roasted ore, it will get reacts with carbon monoxide and gets converted to Fe3O4, and we will get carbon dioxide. Then this Fe3O4, it will further react with carbon monoxide and gets converted to ferrous oxide, and again we will get carbon dioxide. And this carbon dioxide being gas, they will escape out, and ferrous oxide again it will react with carbon monoxide and gets converted to iron. So, it means the roasted ore, that is Fe2O3, so that will gets reduces to spongy iron. So, it means in the zone of combustion, the coke which we have introduced, that will gets converted to carbon dioxide, and the temperature above the tires, they will have raised to 1500 degree centigrade, because the reaction was exothermic in nature. And we know that the exothermic reactions are those reactions in which heat is evolved. And the second zone, the zone of fusion, here the carbon dioxide formed in the zone of combustion, that will get reduced with the coke to carbon monoxide. As this reaction is endothermic in nature, so being endothermic in nature means the heat is absorbed, or so the reaction temperature in this zone, you will say, that will get reduced to 1200 degree centigrade or 1300 degree centigrade. And the carbon monoxide formed in this zone, that will reduces spongy iron, that will reduces the iron oxide to spongy iron, means the iron oxide ore had gets reduced to iron. So, these are the two zones, that is zone of combustion and the zone of fusion. Now, we will come to the next zone. The third zone is the zone of slag formation. As we know that the slag is formed by the combination of the impurities and the flux, and we have introduced the flux, that is at the top of the furnace, that is flux added is the limestone. and limestone is our calcium carbonate. And in this zone the temperature is approximately 800 to 1000 degree centigrade. So, what happens in this zone? In this zone, the first of all the limestone which we have fed at the top of the furnace, that is CaCO3, it will decompose, and it will decompose to calcium oxide and carbon dioxide. The calcium oxide being a flux, it will react with the impurities and forming the slag. So, for example, the calcium oxide, that is a flux and silica is the impurity. This is a basic flux and this is a acidic impurity. The flux will react with impurity, calcium oxide will react with silica and it will form a calcium silicate, that is a slag. So, there is a formation of slag in the zone of slag formation, and being this slag, it is a fusible mass and it is lighter in nature. So, this will comes down and will collect in the lower zone of the blast furnace, as there are two zones are formed or two layers are formed in the blast furnace. In the lower compartment, one will be the you can say layer of the slag, and second will be the layer of the metal. As the slag being lighter in nature, it will come in the upper layer, and the metal being heavier in nature, it will come in the lower layer. So, the slag will collect in the upper layer, and there is a side hole present in the blast furnace, and you can open that hole and you can easily remove the slag and can be thrown away. The last of the zone, that is the zone of reduction, and in this zone the approximate temperature is 400 to 600 degree centigrade. And in this case what happens, as we have already discussed in the last zone, that is the upcupping carbon monoxide, it will react with the iron oxide or the Fe2O3, that is the carbon monoxide which has rises upwards, that will reduces the Fe2O3 to the spongy iron, and the iron it moves down the furnace and melt in the zone of fusion, where the temperature is approximately 1200 to 1300 degree centigrade. And it also dissolves the elements like carbon, phosphorus, silicon along with the iron and collects at the base of the furnace below the slag. So, slag will collect above the molten metal, and from where it is removed, and the molten metal obtained from the base of the blast furnace, and this iron which we have obtained from the hematite ore, this is called the cast iron or the pig iron. So, it means there are 4 zones formed in the case of blast furnace, in which the total process will take place. The 4 zones are the zone of combustion, the zone of fusion, the zone of slag formation and the zone of reduction, in which we have fed the 3 things together. The one is the hematite ore, that is the roasted ore, and second one was the flux, that is the limestone, and third one was the coke, that is the reducing agent, and all 3 together they are known as the charge, and put it in the blast furnace, and the total steps take place into the 4 zones, in which the hematite roasted ore that is converted into iron. So, in this way we have converted the hematite ore into the iron, that is the cast iron or the pig iron. As we have already said in the start of the topic, that is cast iron and pig iron, that is the impure form of iron and is always contaminated with the impurities. So, it means the 5th step, or you can say that is the refining of the metal. What is this refining of metal? Or you can say, if we refine the metal, the automatically this cast iron or pig iron will get purified, means we will remove the impurities from the cast iron and pig iron, and automatically it will get converted into wrought iron, because the wrought iron, that is the purified form of the iron. So, you can also say that the refining of metal, the step can also be called it as the conversion of cast iron or pig iron into wrought iron. That is one and the same thing. So, how can this be carried out? So, this can be carried out, it is done by the puddling process, and in this case the oxidation of the impurities is done by iron oxide, that is again by the hematite ore and air. And in this case the cast iron, which is the impure form of iron, which we also named it as a pig iron, that is placed over the hearth of a reverberatory furnace, which is lined with ferric oxide, that is hematite ore. And in this case the charge, that is the pig iron or the cast iron, is melted with hot gases, and it is then well pedalled with long rods, and which is called the revels. And in this way the cast iron, which is the impure iron, that comes in contact with the lining of the furnace, and the carbon, which is the main impurity in the cast iron, that is oxidized to carbon monoxide. As the reaction written, that is carbon that will react with the Fe2O3, that is iron oxide, and it will get converted to iron, and the carbon which is present as an impurity, that will get oxidized to carbon monoxide and will be removed as an carbon monoxide as a gas. So, the other impurities which is present in the cast iron or the pig iron, like silica, manganese, phosphorus, they will also get oxidized with iron oxide. Silica will be removed as SiO2, manganese will be removed as an Mn2O3, phosphorus will be removed as P2O5. They will also get oxidized to their corresponding oxides and form fusible mass with the basic lining of Fe2O3 and will be removed as an their oxides. So, as we know that the cast iron and the pig iron both are the impure form of iron and are contaminated with the impurities, and the wrought iron, that is the pure form of iron, that is having no impurities. So, if we remove the impurities and the impurities present in the cast iron and the pig iron, they will get oxidized and will be removed as slag, the automatically the cast iron or the pig iron has converted into wrought iron. So, in this way we can refine the metal, and this is the process of the extraction of the iron metal from its hematite ore. So, it means there are total the 5 steps are there, from the extraction of the iron from the hematite ore, that is the crushing, grinding and screening. The second one was the concentration of ore. The third one was although the calcination and roasting is not required, but due to the contamination of hematite ore with iron carbonate, both calcination and roasting is carried out. The fourth step was the reduction of ore, or the fifth step was the refining of a metal, and you can also name it as the conversion of cast iron or pig iron into wrought iron. Now, we will come to the next topic. The next topic is the manufacture of steel. As we know that the steel, it is an alloy of iron and carbon, and it is also contaminated with some other traces of manganese, sulfur, phosphorus and silica. And the percentage of carbon in steel, it lies in between the cast iron and wrought iron. So, in the cast iron, the percentage of carbon is very high, and in the case of wrought iron, the percentage of carbon is very less, that is approximately 0.5%. So, in the case of steel, the percentage of carbon that is in between the cast iron and the wrought iron. So, steel can be obtained in two ways. It can be obtained either by removing a part of carbon from the cast iron or by increasing the carbon content of wrought iron, or by the third method is by mixing the cast iron and wrought iron in exact proportions. So, again I am repeating that the steel can be obtained in three ways, as steel is having more carbon content